Exploring today substances and mixtures, our third of 4 presentations. The last one is quite significant in length, but we'll break that up into pieces. Our success criteria, today we're going to look at distinguish, as our command term, between each of the following sets of items. Pure substance and a mixture, and giving examples thereof, of pure substances and of mixtures. A solution versus a suspension, a solute against a solvent, and the terms dilute, concentrated, and saturated. Okay, so here we go. These are our 4 different terms or pairs of terms to consider. Let's start off with pure. Pure substance is something that is only made up of that type of substance. So, for example, we can have pure water only contains water molecules. So it's got no salt in there, it's got no sugar, it's got no other contaminants. It's only water molecules. We can have pure gold. So that is a substance.
Is carat gold like a type of gold?
Carat relates to the level of purity of gold. Yeah? 24 karat gold. Carat not as in C-A-R-R-O-T, but as in K-A-R-A-T. Yeah? K-A-R-A-T. Slightly different. It's a measure of purity. 24 is considered pure, right? So that's a high purity of gold. Question?
I know there are 3 different spellings of carat, all of which have different definitions.
Oh.
Are there any more?
Not to, well, it could be, not to my understanding. So water, gold, pure gold is simply all made up of gold atoms. Pure oxygen is oxygen that is made up of just oxygen molecules. Yeah, so something like white gold is not pure gold, because white gold contains little bits of platinum in it, little bits of other substances that manipulate and change the color. Rose gold contains little bits of copper, right?
It's gold, silver, like I can't remember what it's called. The alloy of gold and silver.
I'm not sure what that is. You've got things like brass, that's an alloy of copper, nickel, and something else. Bronze is something similar as well. Alloys are mixtures. Thank you. So a mixture is made up of 2 or more pure substances. The difference is that they are physically combined. So they're not chemically combined together. Mixture is different pure substances mixed together. So we can physically separate them. So salt and water, salty water, can be separated. We can boil the water off that leaves the salt behind. Same thing as sugar water, etc. Yeah, so they are mixtures. Alloy are physical. We can separate them. Because an alloy is not a compound. A compound cannot be physically separated. So sodium chloride, table salt, is a compound, not a mixture. We can have pure table salt that's only made up of sodium and chloride ions. Yeah? Pure simply means only made up of one type of substance. So salt water is not pure. It's got water molecules. It's got the components of salt ions in there. Yes, Sam?
Is steel?
Steel is an alloy. It's a mixture. It contains both iron and carbon. Stainless steel is slightly different again. It's got little bits of chromium, other components as well. Okay. Air. Air is a mixture, right? It's 78% nitrogen, it's 21% oxygen, 1% argon, 0.04% carbon dioxide, and other smaller components. Yeah. The nitrogen within the air has no use to you. Despite it making up most of the atmosphere, we can't utilize it. Even plants can't utilize nitrogen directly. It means they cannot absorb the nitrogen directly from the atmosphere. Yeah? Plants in their root nodules, so in their root system, have a symbiotic relationship with bacterium, and there's particular bacterium that is then able to take the nitrogen, making it into a soluble form for the plants to be able to use. Then plants take the carbon dioxide from the air, the nitrogen, soluble nitrogen from the soil, to build some more of those life molecules, and then we eat the plants and get the nutrients that way. Soil is a mixture. It's a mixture of, well, there's biotic organisms within there, there's dirt, there's all sorts of other components within soil. So I've gone through those already. Our 3 examples that I provided. Water is only made up of water molecules. Gold is only made up of gold atoms. Oxygen only made up of oxygen molecules. There's our mixtures that I've spoken about. Here's an example of a model of soil. It's rather complicated because soil is very complicated. Soil is not the same as dirt. Dirt is abiotic, meaning dirt does not contain life. Soil is biotic. It's got microorganisms all through it. Soil is put plants into soil because we need that life, that nutrients. Dirt is not very nutrient rich, doesn't have biotic organisms that help to break down some other organic matter. Okay, second pair of substances is a solution versus a suspension. A solution is where one substance is dissolved into another. So sugar dissolved into water, salt dissolved into water. In a solution, the particles are evenly distributed. So we can't tell one part of the solution different to another. So, anyone drank a Powerade recently? Yes. Notice how it all looks the same. But within there, you've got electrolytes, you've got sugar, you've got colouring. Yeah? But it's a solution because all the components of what's been dissolved is indistinguishable from the rest of what you're drinking. Yeah? It's all mixed together evenly. A suspension is different. So an example is dirty water is a suspension. If you let dirty water sit still long enough, the dirt will settle to the bottom. Yeah? Yeah. Okay. So a suspension is where the particles can be seen suspended, right? Or they are distinguishable from the remaining water or whatever around it. They're not evenly distributed. They may settle to the bottom. Muddy water, sand in water. Blood is an example. If we spin blood very quickly, it will separate into different components. Yeah. So blood isn't a mixture. It's a suspension. Okay. Third out of our 4 sets of terms. Solute and solvent. Solute is what dissolves. A solvent is the thing that does the dissolving. So salt water, the salt is the solute, and the water is the solvent. Sugar water, the sugar is the solute, the water is the solvent. Yeah? A cup of coffee, the coffee grounds, not that you drink instant, right? But the coffee grounds are the solute, the water is the solvent. For anyone who's worn nail polish, you can remove nail polish using acetone. Acetone is a solvent. It will break down nail polish because nail polish can dissolve in acetone. Nail polish won't dissolve in water.
So would another example be iridium in something like fluoranic acid?
Acids tend to contain water. They're a solution of an acid in the water. Yeah? You can get highly concentrated acids that will break down things like protein. So where there's more acid components than water. Last set of terms. Last 2 more slides after this. And the 3 terms that are related are dilute, concentrated, and saturated. No. Just an example. So dilute simply means having a small amount of solute dissolved in the solvent. Sometimes we mix this up with the term weak. Whereas in chemistry, we use the term weak and strong to mean something different. So someone who has a weak cup of coffee isn't actually weak. It's dilute. Snake. So imagine, how do you like your cordial? Do you like your cordial with a little bit of cordial? Or do you like your cordial with a lot of cordial? Yep. My eyes are starting to water. Right? So lots of cordial, small amount of water. Small amount of cordial, lots of water. That's the difference between dilute and concentrated. Dilute, small amount of solute, large amounts of solvent. This is the way I like my cordial. This is the way I like my Milo in milk. Who's to say?
I like them not very.
You like them very, very concentrated, not strong. Concentrated. So if your parents drink coffee and they talk about having a strong coffee, you go, concentrated coffee, not strong. Lastly, the term saturated. When you think of the word saturated, what do you think?
Wet.
Wet, saturated. So If you're wearing a jumper and you are saturated, it means that your jumper cannot contain any more water. Yeah? So it's fully soaked with water. So a saturated solution is one in which cannot contain more solute dissolved. Yeah? It's got the maximum amount of solute that can be dissolved. However, the amount of solute that can be dissolved in a solution is dependent on temperature. Generally, what it means is that the higher the temperature, we can dissolve a bit more. We can create what's called a supersaturated solution by increasing the temperature, dissolving more, and then cooling. And so what happens is that there's a little bit of energy and it's not stable. So what's happening here, where the little Easter egg is that this is a supersaturated solution of sodium ethanoate. By adding a tiny little crystal to the center of this solution means that the excess amount that is dissolved in will crystallize out. And there we go. This is what we've covered today. We've covered the difference between, thank you, pure substance in a mixture, solution versus suspension, solute versus solvent, and the terms dilute, concentrated, and saturated.